Dear Professor, I'm Gao Shenhan. I would like to submit my homework to number 1 about to design a physiological controller by 9 times 9 matrix triangular membership functions. And next, I will introduce how is fuzzy logic control. And next, fuzzy means not clear, blurred, which means it can be applied to those complex systems successfully whose mathematical formulation is not clear or well defined. Next, fuzzy logical controllers are mainly divided into 3 processes. Number 1, fuzzification is the converting input process quantity such as temperature, pressure, velocity, etc. Into membership values in a fuzzy set. For example, converting the article measured temperature values into membership degree of fuzzy language. Variables such as cold, moderate, and hot is to enable the controller to handle human language like fuzzy information. And number 2 is ruler-based evolution. The iteration bases are preset for the controller rules, presented in the form of if some, then something, such as if the temperature is low and the temperature change rate is negative, then increases the heating power. Determine the corresponding control strictly by matching the input for the quantity and performing logical operation. And next, 3, the fuzzification is covariant the fuzzy output obtained through rules evolution into precise control output, which is used to drive autos such as motors, valves, ECTs. To control the controlled object. For example, the temperature control of an air conditioner. When we feel that the room is a little hot, the air conditioner does not need to accurately know how much the temperature has risen, but instead adjusted the cooling power appropriately based on the fuzzy information of a little hot. If it's very hot, increase the cooling force, which is a simple application of fuzzy logical controllers in practice. And next, we will focus on designing a fuzzy logical controller by 9 times 9 matrix triangular membership function, and see the specific steps. The first step is to define the input and output. Taking the temperature controller system as an example, the input variables are the area between the article temperature and the set temperature, as well as the rate of change of the error, and the output variable is control signal of the heating or cooling equipment. And next, we need to open MATLAB software and write fuzzy. It will give us a fully logical design windows. And next, we need to add variables for two input, E and delta E. And next, we need to define the fuzzy sets, define line fuzzy sets for each input and output variable. Those figure set below the range of variable values. And step 3, determine the range of variable values. Determine the range of values of each input and output variable based on the article variation range of the variables. For example, the range of temperature error is -10 to 10 temperature. The range of error change rate is -5 to 5, and the range of control signal is 0 to 100. And next step, construct a triangular membership function. The membership function of a triangle is determined by 3 parameters, namely the two base vertices and vertices of the triangle. Is for delta E. Output. And the next step, build a fuzzy rules library. Due to the presence of two input variables, each input variable has 9 fuzzy sets, resulting in a line times line matrix structure. The rows and columns of the matrix correspond to different fuzzy sets of two input variables, and each element in the matrix corresponds to a fuzzy rule. The basic logic of this rule matrix is that when the temperature error is negative and the rate of error change is also negative, a large control signal needs to be output to quickly increase the temperature. When the temperature error approaches 0 and the rate of error change is also close to 0, the control signal should approach 0 to maintain stability. And so we can obtain such a line times line matrix diagram, which can be used for subsequent fuzzy rules formulation, for the enforce, and for the resolution operation to achieve control of the system. And next, we need add rules about 81 rules to the software. And next, they click view surface to generate a 3D surface map that shows the relationship between two input variables and one output variable. The x and y axis represent input variables, while the z-axis represents output variables. Color coding displays different output value ranges, and clicked value rules to generate this rule video interface, which allow users to value the adult the rules for the logical system. And next, the final step is to differentiate. We use Simonic to design this circuit diagram, which consists of the temperature change singular response by a sine wave and target. Temperature singular response by a fixed value of 3. The temperature error and other inputs are processed by a further logical controller model to output control singular. Reflects the relationship between temperature error, temperature change rate, and control singulars. And finally, we obtained their waveform diagrams from the comparison of data. It can be seen that without the full logical controller, the temperature fluctuation is larger because its control method is singular, and the energy consumption is also high, because regardless of the temperature difference and cooling power operates is a fixed mode. After adding a further logical controller, temperature fluctuations were significantly reduced, able to be maintained within a more stable range, and energy consumption was also reduced, achieving more efficient and accurate control. And this is all my introduction of homework about homework 2 number 1. To design a further logical controller by 9 times 9 matrix triangular membership functions. Thanks for watching.